Hello all. In this video I would like to cover an easy but important topic because I see this you'll get asked about this topic in questions mostly. Going through differential equations from transfer functions or going to transfer functions from differential equations. To make this happen we use a transformation called Laplace and inverse Laplace. If you Google what Laplace is onto YouTube or Google, you will probably see a long list where there is some frequency domain functions, the S functions, and also some time domain functions, the denoted by T. But we don't use them on these particular questions because there's so many different functions of frequency domain and their corresponding Laplace transforms. For this type of questions, only knowing the Laplace of derivative and some couple ones, but easy ones, will be enough for you. So let's get started. I think you will understand what we will do when we get to solve some examples. Well, you see there's the general expression of the Laplace of derivative. So f zeros mean initial conditions, and fs is Laplace form of f, and ft is the normal, the time domain representation of f, the function f. So if there's a first order derivation and you ask to apply a Laplace to find this frequency domain response or frequency domain, let's say, representation, you will just put 1 instead of this n. So f to the first derivative t equals s to the power of 1 fs minus s 1 minus 1 0, so here's 1 f0, and this goes for all the values of derivative. So I just wrote down the maximum second derivative. So the second order derivation is going to be put 2 instead of n, f the second derivative, so s to the power of 2 fs minus 2 minus 1 1 s times f0 minus 2 minus 2 is 0, s to the power of 0 is 1, f the first derivative 0. So that's the whole thing you will use when you get to ask find this transfer function from this differential equation, or maybe you get to ask find some responses of this differential equation. So first, let me do this easy example to get you warmed up for the upcoming topic. So since you all know, I mean, if there's a given differential equation, you will probably ask to find the transfer function, right? And the transfer functions we covered in previous video is gs, which equals to cs over rs. I didn't write it down, but of course in the question you will see it says r is the input function or c is the output function, but it can be different. So instead of c they can write y or other letters, but they must indicate which function stands for which type of, let's say, function, so input, output, or etc. And since we know our aim is to get this one, let's start down by writing this easy conversion. So we have here the first degree derivative, right? And we have ct inside of it. So but also for the most questions the initial conditions are accepted to be 0. If it's not given anything, just I was putting 0, but maybe 10% or 5% of questions that in the question you will see take f0 as 1, f0 is 5, or etc. It can give you some values, but mostly initial conditions are get to be 0. So let's write this down quick. So first derivative we have here, and initial conditions are 0. So the first derivative comes up to be s c s, right? Plus, if there's no derivative, just write as switching the letters, 2cs equals rs. And let's take those cs's into a same parentheses. We have cs in the parentheses s plus 2 equals rs. And take this s plus 2 down, rs2 down, we will have our gs 1 over s plus 2. That's the whole thing. That's the most basic example you can see on this topic. So as the questions go, we will get to see some difficult questions, but let's go to the second one. It says, use the result of previous example to find the response CT to an input unit step. Well, on this one, we are given GS because we found it on the previous question, and it says, for a unit step, find the response CT. So first, I will find CS, all right? But keep in mind, guys, we said GS is CS over RS. By this manner, CS is GS times RS, right? Let's write it down, GS times RS. And in frequency domain, unit step corresponds to 1 over S. You should know it. That's a basic information. And this function goes to be 1 over S plus 2 times 1 over S, right? That's simple. But in order to find a response, we need to separate those two parentheses in let's say, in a certain part. So let me do this basic conversion. We were doing it in previous courses, but maybe you need to, let's say, memorize it. There's a thing called partial fraction expansion, right? Let's say, write it, partial fraction expansion. Right. So that we had 1, so we had this formula, 1 over S plus 2 times 1S. So we will separate it into two parentheses. So let's say we have A over S plus 2 plus B over S, which equals 1 S times S plus 2. So what I'm gonna do is usually I just equate these denominators, and I will have A times S plus B times S plus 2 equals 1, right? I just equated all the numerators. So put S as minus 2 to get rid of this B. We will have minus A over 2 equals 1. So A is minus 1 over 2. And with the same manner, we will put 0 into S, and we will find our B is 1 over 2. So the whole function comes up to be, let's write down B part first. So 1 over 2 over S plus, minus 1 over 2 S plus 2. So this is our CS, guys. All right. And if you get asked to find the time response, CT, we will apply inverse Laplace, right? So let's write it down. In inverse Laplace, if there's let's say if there's only one S at the denominator, it means it's a constant value. So we will get to find 1 over 2. And if there is anything like S plus 2, S plus 4, but there is no S's on the numerator part, it corresponds to our exponential function. So we will write down 1 over 2 e to the power of minus 2. Well, this is CT, and I'm just letting you know, it's a general information. The constant part is we call the forced response. And if we have something like exponentials and exponential minus something, it will be natural response. Because, guys, as t approaches to infinity, this part will go to 0, right? And this is how let's say this system works as naturally. Naturally, all the systems go to 0. But this doesn't go to 0 because it's the let's say part of the input. It's a contribution of our input, and input is not something natural. We force it. So that's why it's forced response. Just keep in mind, maybe in upcoming videos we will talk about this again, but just letting you know, I think that's a crucial part to understand the responses. And we will have another easy example here. We are given a differential equation, and we need to get the transfer function, the corresponding transfer function. So again, all the initial conditions are get to be 0. So let's write down, if there is the third degree, just write S cube CS. plus 2 s squared cs plus 7 s cs plus 5 cs equals second derivative s squared rs plus 4s rs plus 3rs. So let's take into parentheses of cs and rs to get rgs, right? In the parentheses of cs we have s squared plus 3s cubed plus 3s squared plus 7s plus 5, which is rs parentheses s squared plus 4s plus 3. Lastly, we will get to find our gs, which is cs over rs, right? So it's going to be easy. Like, just take this down, and let me just write it here. S squared plus 4s plus 3 over s cubed plus 3s squared plus 7s plus 5. This is gs. All right. We have another example here. But this time we will go from transfer function into a differential equation. So we have this expression is given here. So let me write down gs in terms of cs and rs, right? I'm writing down as it was. And yeah, so let's do this multiplication for each part. So cs 2s, s squared 6s plus 2 equals rs 2s plus 1. By the way, I solve questions as I get used to, but they might be different, so just relax. And all right, so let's make this large, and we will have s squared cs 6s cs plus 2cs equals 2s rs plus rs. Yeah, so how we can convert this into the time function in terms of t, right? That's what we were doing previous example. So s squared cs will be d at the second derivative, it's like second, and this, it's so easy. I directly write cs to ct because there is no derivation. At the first dr dt plus rt. That's the whole case. So this is our differential equation. So the different thing is, in the previous examples, we always come from, we mostly come from a transfer function to time response, or let's say differential equation, not time response. But in this one, we came from a transfer function to find this differential equation. Yeah. So we will have the last example here, and it says find the ramp response for gs given by this formula. So ramp response in let's say frequency domain corresponds to 1 over s squared, right? So let's write it down. So ramp response for gs. By the way, if it asks you about some response, you need to get cs. So again, I will write cs equals to rs times gs, which is 1 over s squared s, s plus 4, s plus 8, right? Let's take this into 1 and let this go. So we will have 3 denominator contributions, s, s plus 4, s plus 8, right? So we will have a, b, c, 3 different denominators. So let's write it down. A over s plus b over s plus 4 plus c s plus 8, which is 1 over s, s plus 4, s plus 8. Yeah, and let's equate all the denominators. So we will have a, s plus 4, s plus 8. Let me write this down into whole paper, so I need space. Yeah, a, s plus 4, s plus 8 plus b, s, s plus 8. If you missed out something, please pause the video and try to understand what I'm doing, right? Plus c, s, s plus 4 equals 1. What I did is I just equated the denominators and then the numerators, because if the denominators are same, the numerators of each side should be same. And now let me put s equals minus 4. So if I put this value, the a part is gone, the c part is gone, so we will have only b part, and b gets to be minus 4 times 4 equals 1. So minus 16b is 1, so b is minus 1 over 16. And let me put 0 into s, so b is gone and c part is gone, so we will have a times 4 times 8, which equals 1. So we will have 32a is 1 and a is 1 over 32. And lastly, let's put minus 8 into s. So a is gone, b is gone, so we will have c times minus 8 times minus 4. And it's going to be minus 32, c is 1, and c is 1 minus 1 over 32. So our function came in a way where we have 1, 32, s minus 1 over 16, s plus 8, no, 4, plus 1 over 32 or s plus 8. So this is our CS, guys. So we found our CS, right? Like we did in the previous example. I just put this because there is 3 separations, a bit harder, but I think it's also, let's say, doable. And if we get to find our CT by applying inverse Laplace, so I told you, for the first part, if there's a only s in denominator part, just write down 1 over 32. Minus, if there's only s plus something or s minus something, it will be like 1 over 16 times e to the power of minus 40. And with the same manner, you will have e to the power of minus 80. Again, I'm repeating, so this is our response, but this part, this constant value is the forced response. And those two, since those two go to 0, both, they go to 0, we will call that natural response. Yeah, in this video, that is all I'm gonna, let's say, show you. I hope this video was helpful, and you can ask me questions from the comments below, but I hope this video was funny, not boring to you, and I hope to see you again in the upcoming videos. Catch you up later, and goodbye.